For each of the following quadratic functions, find the vertex hk and determine if it represents the maximum or minimum of the function. One way to do that is to recognize that all the functions that are given in parts A through D are in vertex form. In other words, all the functions have the form f of x is equal to a times the square of x minus h plus k. So they have a vertex of hk, and the graph opens upward if a is positive and opens downward when a is negative. So for example, in part A, the value of a is -2. That means that the parabola opens downward and it's going to have a maximum. The maximum will occur at the vertex, and the vertex will be 3, 5. Without memorizing the vertex form, we could think about the function in the following way. Focus on the term -2 times the square of x minus 3. We know that the square of x minus 3 is not negative. So when we multiply that by -2, we know that the whole expression is never positive. The expression is always negative, or the largest value that it can attain is 0. So what we want to do is to think, what is the value of x that would cause this first expression to be 0? And we see that if x is 3, we would get 3 minus 3 is 0, the square of 0 is 0, 0 times -2 is 0. So you're thinking about what number makes the value inside of the parentheses equal to 0. In this case, that is 3, and therefore the x-coordinate of our vertex is 3. Now what is the value of the function when x is equal to 3? Well, this first expression is equal to 0, and then to that we need to add 5, and 0 plus 5 is 5, so the vertex is 3, 5. Now we've already said that this first term is never positive, so that means that we're going to be taking away something from 5, which means that 5 is the maximum value of this particular function, and therefore the vertex is a maximum. We can use our calculator to visually see that this is correct. Go to y equals and enter the function -2 times the square of x minus 3 plus 5. And then create a good viewing window. I'm going to go to Zoom and select number 6, Zoom Standard. Notice that the graph is a parabola that opens down, and therefore it has a maximum. The maximum occurs at the vertex, and the vertex is 3, 5. In part B, we're given the quadratic function f of x is equal to 1.6 times the square of x plus 1 plus 8. So again, we focus on this first term. The square of x plus 1 cannot be negative. So when we multiply by positive 1.6, that means that this whole first expression in blue cannot be negative. Therefore, the smallest value that it can be is 0. And what's the value of x that causes this expression to be equal to 0? Well, x must be -1, because -1 plus 1 is equal to 0. So the x-coordinate of the vertex is -1. And when we substitute -1 into the function, the first term is 0, and to that we need to add 8. So the value of the function is 8. And we're always adding non-negative values to 8, so that means that the vertex is a minimum. Again, we can use our calculator to double check. Go to y equals, clear out our first function, enter our new function 1.6 times the square of x plus 1. And then add 8. Sketch the graph. And we notice that the graph is a parabola that opens upward, and it seems reasonable that the vertex is at -1, 8. For part C, we're given the quadratic function f of x is equal to -5 times the square of x plus 4 minus 7. Our first term, -5 times the square of x plus 4, is never positive. Therefore, its maximum value is 0. The expression is equal to 0 when x is equal to -4. -4 plus 4 is 0. The square of 0 is 0. 0 times -5 is 0. So the x-coordinate of the vertex is -4. And when we substitute -4 into the function, the result is -7. So our vertex is -4, -7. Since the parabola opens downward, the vertex is a maximum. For part D, we're given the quadratic function f of x is equal to 8 times the square of x minus 2 minus 6. Notice that the first term is never negative. Therefore, the smallest value that it can be is 0. The value of the expression is 0 when x is equal to the number 2, because 2 minus 2 is equal to 0. So the x-coordinate of the vertex is 2. When we substitute 2 for x in the function, the result is -6. So the vertex is 2, -6. Our a value of 8 is positive, so the parabola opens up. Our vertex is a minimum.